Science friends. We are going to learn about two new gas laws today. The first one is called Gay-Lussac's law, and the second one is called the combined gas law. So let's get started with these. So Gay-Lussac's law, as it's written here, is looking at pressure and temperature. So we see that the pressure of a gas is directly proportional to the Kelvin temperature if the volume remains constant, okay? So basically what that means, as temperature goes up, pressure goes up. And we've talked about that before, right? So as temperature goes up, temperature is a measure of kinetic energy. Those molecules are gonna be bouncing off the walls of whatever the gas is, the chamber that the gas is being held in, and it's gonna cause more pressure inside that chamber or whatever it is. And so as temperature climbs, pressure also climbs, assuming the volume remains the same. Now, if the volume changes, then it's going to be a different scenario, okay? And so again, with these, we have to look at the Kelvin temperature. So all of your calculations that you're going to do today, you want to make sure that you convert those Celsius temperatures to Kelvin by adding 273. So let's do a practice together with Gay-Lussac's law, and then I'll turn you loose to try a couple on your own. So the gas left in a used can is at a pressure of 103 kPa, so I'm going to call that my P1, okay, at 25 degrees Celsius. So that's going to be my T1. All right, if this can is thrown onto a fire, what is the pressure of the gas when the temperature, okay, so this will be T2, reaches 928 degrees Celsius? Okay, so again, we're going to use this formula. P1 over T1 equals P2 over T2. All right, and so we're going to plug in that first pressure. So that's 103 kPa, all right? And then times the temperature, but we're going to need to convert that to Kelvin. So 275 plus 273 is 298 Kelvin. I'm sorry, I should have put, let's ignore that. Okay, let me read that again. 103 kPa over, 298 Kelvin. And then P2 is what we're trying to find. And then T2 is 928 plus 273, because we also have to convert that one to Kelvin. And so it should be 1,201 K. All right. And so just like we did with the other ones, we are going to cross multiply. So we'll multiply 103 times 1,201. And then we will divide by 298. So 103 times 1,201, okay, and then divided by 298. And so what I got for my P2 is 415.11, okay? And you can see here that your K's are going to cross out, leaving you with the units of kPa. And because this is a pressure, we know that that unit makes sense, okay? And if I didn't already say this in the last lesson, you do have to make sure your units match, okay? So if I had this pressure in kPa, I have to make sure my other pressures are in kPa. All right, so now this one we were solving for pressure, so it wasn't a big deal. But if you had, maybe if you were solving for temperature, you can't use a pressure in kPa and then a pressure in torr. Okay, they both have to be in the same unit, so you have to convert one to the other. And it doesn't matter which one you convert as long as they're both in the same unit, okay? So again, this is just another thing where you figure out which one goes with which and then plug and chug to get your answer. So you have two practice problems there to do on your own. So I'm going to pause here and let you do those, and then we'll come back together and look at them in just a second. So if we take a look here at these, the first answer you should have got 340.9 kPa, okay? And so we just put in our numbers from our problem. Pressure 1 was 198, We had to convert to Kelvin with that temperature to be 300. Pressure 2 was 225, and then we solved for temperature 2. So here we cross multiplied those two and then divided by 198. All right. And then on the second one, you should have got 2.58. Again, just plugging pressure, temperature. These were already in Kelvin, so those didn't have to be converted. So that made it a little bit faster there. So we cross multiplied here and then divided by 539. And you should have got a pressure of 2.58 kPa on that one. Okay. So now let's look at the combined gas law. So the combined gas law, all of these other ones, it says, assume the volume is not changed. Assume the volume does not change. And then on Boyle's and Charles's law, assume the temperature or the pressure or whatever doesn't change. But what if they do change? Well, if they do change, then we have to use the combined gas law. If you have different pressures, volumes, and temperatures in both scenarios, then we use a different formula. And so that's P1 times V1 over T1 equals P2 times V2 over T2. And that's just all of these equations put together. We've done every combination of this equation. We've done P over T equals P over T. We've done PV equals PV, right? And we've done V over T equals V over T. Those are Boyle's law, Charles's law, and Gay-Lussac's law. Not necessarily in that specific order. But this is the combined gas law that kind of puts all of those three together. Okay, so let's take a look at a practice problem with it. Again, you have to have your temperature is in Kelvin, and you have to make sure that your other units for pressure or whatever match. Okay, so the volume of a gas-filled balloon, let's go back. A gas-filled balloon is 30 liters, so we're going to put that as V1, okay, at 40 degrees Celsius, so that will be T1, and then 153 kPa will be a pressure one, okay. What volume, so that's what we're trying to find, so we're going to solve for V2, that's our question mark, will the balloon have at standard temperature and pressure? Now, this one is just a little bit tricky because you might look at there and you say, all right, let's put this in. P1 V1 over T1 equals P2 V2 over T2. And so we're going to plug in and we're going to say 153 kPa is our pressure. And then V1 we put as 30 liters from right here. Okay, so we've got our pressure and our volume. And then T1 was 40 degrees Celsius, so 40 plus 273 is 313 K, once we convert to Kelvin, equals V2 we know is what we're trying to solve for, so we'll just leave that written as V2. But then you might say, Ms. Brown, I don't have any other numbers to put in here. Well, sometimes the problem will give you other numbers to put in there. And I think in both of your practice problems, it does give you other numbers to put in there. But sometimes it may do like this one and say at standard temperature and pressure. And so you have to ask yourself, what is standard temperature and pressure? Okay. Well, we're dealing with kPa here. So we know that standard pressure in kPa is 101.3 kPa, okay? Standard temperature is 273 K, okay? And so we'll put in 273 K. Had you have had your units to be in something other than kPa, maybe if they were in ATMs, you would have put 1 ATM as your standard pressure, or 760 torr or 760 mmHgs. But you put in those standards there, the pressure that matches here, okay? And so standard volume is 22.4. I don't think you ever actually have to use that, but standard volume is 22.4, Okay, so for this one, we're going to go ahead and solve. And so the way that I personally choose to solve these is I like to solve this half of the equation first. So I'm going to multiply 153 times 30 and then divided by 313. Okay, and I got 14.66. All right, now over here, now what I like to do is I like to divide this part. So 101.3 divided by 273. And I still have that V2 on the top. Okay, so this leaves me 0.37 V2. Okay, and then I divide basically both sides by 0.37, so that crosses out. And I divide this by 0.37, just like you would in algebra. So 14.66 divided by 0.37, and I get V2 to be equal to 39.6. Okay, now we should know that a volume, the unit of volume, is in liters. But I also just can double check up here. I can cross out my kPAs because there's 2 of those. I can cross out my kelvins because there's 2 of those. And all that's left is liters. And so that confirms that that is correct there. So 39.6 liters, okay? So these are just a little bit more difficult, but I have full confidence that you all can do them. So go ahead and pause right here and try the next 2 on your own, and then I will go over them in just a moment. So looking at these practice problems here, you should have gotten 0.34 liters for the first one and 126.2 kPa for the second one, okay? Here in the problem, I've underlined all of the numbers that I was given and I labeled them, okay? This one I had to solve for V2, and so I multiplied 155 times 1 divided by 298, and I got 0.52. And then I also divided 605 divided by 398, and I got 1.52 times the V2 that's still there. And so when I divided 0.52 by 1.52, then I got this 0.34 liters. Okay. On the second one, it was set up pretty much the same way. I underlined everything, all of the units that I did, and I labeled them to begin with. I converted my temperatures to Kelvin, and then I plugged them into my problem. And then when I solved, I multiplied 107 times 5, and then I divided that by 227, and I got 2.36. Over here, I divided 7 by 375, and I got 0.0187. So then when I divided 2.36 by 0.0187 to get P2 by itself, then I got 126.2. And that was the answer on that one. Okay? So on your assignment today, you have if you got it picked up printed, it's one worksheet front and back. It says Gay-Lussac on the top, and then it says combined gas law on the next page on the back side. Okay, so you have that assignment to complete and then upload it in Google Classroom. If you have any questions, then let me know, and if not, then you all have a great day.